Good morning all the students, how are you? I hope you all are best and fine. And now we are going to discuss about our the concept of refraction of light at curved surfaces. In that one, we are going with the numerical examples. Yes, unfortunately, there is due to the request of parents and as well as our students due to the festival. Travelings and as well as all these things may disturb our examinations. That's why there is our examinations are postponed. I hope all the students today there is one of the important government meeting is going on our education system, and we hope best for us. Yes, if they immediately open for our classes, it is good for you and as well as for all the schools and teachers. Yes, we'll get somewhat information for today's. It is a good day for us. I hope for 10th class students especially, because till now there is any no government decision is not there. When our examinations, when it is our what is the academic calendar, how to follow that our classes and everything will be way here today, may announced by the government. I hope. Yes, hope for best. And all the students be prepared for that our schedules, whatever coming schedules. It is a very busy schedule for you. Why? Because I hope there is you all are completed our internal assessments and everything. If you not completed, once go through our branches and as well as you collect the material and complete it as possible as early. After the decision is coming from our government, once again I will give the somewhat suggestion to you how to maintain all these things. Already they are given, somewhat lessons are deleted. Don't confuse about our deletions of our topic, and in the 5th lesson only some part topic only deleted, not total lesson is not deleted for examination. Yes. Yeah, and now we are going to discuss about our concept of whatever image formation formula is there on that one, somewhat numerical problems. Yeah, not totally deleted, only some part of the lesson is only deleted, not totally deleted. Partial part only, the prism, based on the prism, whatever the component are there, that is only deleted. Whatever eye defects and as well as eye constructions, everything will be there in our syllabus. Only the prism, dispersion of prism, that is only deleted from our syllabus. Remaining as usual only. Yeah. Well, students, there is now go with that page number 62 and whatever the examples are there. Okay, now once we go through that examples, whatever the numerical problem examples are there, once you go through that example, here example number 1, a bird flying down vertically toward the surface of water in a pond, yes, with a constant speed. There is a fish inside the water. If that fish is exactly vertically below the bird, then the bird will appear to the fish to be. Okay. Yes, you know very well about this thing already. In the 9th class also you have it here. The same question we have here in 9th class also. Here once again I repeat it. A bird flying down vertically toward the surface of water in a pond. Yes, with a constant speed, there is a fish inside the water. If that fish is exactly vertically below the board, then the board will appear to be fish to be. Yes, further away than the distance, actual distance, closer than actual distance, moving faster than its actual speed, moving slower than its actual speed. Which of the 4 options are true? How can you prove it? Okay, there is a once that is only we have to go for it. You know very well. First thing, there is a what is going on because of refraction. The lateral shift or vertical shift is going on because of the refraction of the any situation. Okay, clear or not, all the students? You already know very well. You about how the light ray is refracted through the glass slab. Okay, now in a 9th class already I discussed it. It is a original ray. Suppose it is a normal. In case it will be comes towards the normal. Okay, now it will be traveled like that, and then after again it will be what here? It is a one more normal. It is a rarer media. That's why it goes like that. Okay, clear or not, all the students? There is a laterally the shift will be get for us. Okay, clear or not, all the students? Laterally the shift will be get for us. Okay, what is the lateral shift? This is only the lateral shift. Okay, clear or not, all the students? Now there is a what? It is a one is a parallel to the another one only, but lateral shift will be get for us because of the any refracted surface. Got it or not, all the students? I hope you got it. This information. Yes, this is only. Once again, I repeat it here. Just listen carefully. Yes, there is a what will be going on. There is a it is a incident light. It may be normal. It is incident angle. You know very well. It will come towards the normal, and it is what actually refracted angle here. Again here normal will be there. Okay, now there is a what it will be go away from the normal. Now once check it here. Okay, in case it is not deviated, our ray is not deviated, it will be moves in this particular direction. This ray is moves in this direction. Okay, one is the parallel with the another one. What is the changes are there? Just lateral shift is there. One is the parallel with another one. Lateral shift will be get for us. Here also compulsory lateral shift is there. Whatever the appearance is there, that will be not a correct thing. It laterally shifted. Okay, clear or not, all the students? Once you go through it here, there is a what is the diagram? Example number 1 we have taken. Yes, this is only the diagram. There is a we have taken a water here. In this water, there is a fish is somewhat here. Fish is there. Here there is a one more thing, and there is a one board will be there here. Clear or not, all the students? One board will be there. The board actually the vertically it is a what actually this is only vertical thing. But the fish is not here. You know very well. There is a actually where it will be appear. Yes. When there is a board is coming nearer to it here, automatically the light ray coming from the fish it will be. It is a bended. Suppose you take it is a surface of water. Yes, and now there is automatically It is a bended outward normal from the where, from whatever the light rays are coming from here. Suppose it is only taken as a normal, it will be go away from this particular ray. Okay, clear or not all of you? Light rays will go away from the normal. Understood not all of you students? And now there is a what? It is a plane surface. Okay, clear or not all the students? Plane surface. That's why you applied our whatever the image formula is there for a plane surface. What is that image formula? Already yesterday also we have discussed. That is only our image formula for our refraction. It will be taken as n2 by v minus n1 by e is equal to taken as n2 minus n1 by r. n2 minus n1 by r. Here there is a refractive index is the infinitive for the what our plane surfaces. It is a what is the plane surfaces na. Here it is a plane surface. That's why there is r is equal to taken as infinity. This becomes 0. Now it is also written as n2 by v minus n1 by u is equal to 0. Now it is also written as n2 by v is equal to n1 by u. This is only the principle we are taken for the what for a plane surface. Now that is the what we have to take here. There is you have to take here. Yes, when our light ray enter from water to yes this our board. So first thing is about initial height. It will be taken as x here. The refractive index of the water is taken as n here, and the refractive index of water it will be taken as n1 here. Okay, clear or not all the students? And as well as the distance between object and as well as our bird is taken as x here, and as well as yeah, here there is actually our object distance is at where at x here. Here actually the fish is only observed. There is our board. That's why it will be taken here. Okay, not at actual distance. It is a vertical shift. It will appear for us. And now there is whatever the values are there. First, that is only how to take here. It is actual distance from the fish to here. That is taken as x. But up here distance should not same as actual distance. That will be taken as y. It is taken as v, and as well as here u is taken as x here. The both are the minus values only takes here. And the next one is what we are taken here. n1 is equal to taken as a. That is a refractive index. A refractive index. You know very well, n1 is equal to taken as what? n1 is equal to taken as a 1. You know very well about that. Refractive index of air is a 1. And there is a what? N is another value that is only taken as refractive index of the water. Refractive index of water it is. Here automatically you know very well n2 is equal to taken as n. n1 is equal to taken as a 1 here. The two values are substituted in this particular place. And one more is also given. V is equal to, we are taken it is as a minus y. U is equal to taken as a minus x. Okay, clear or not all of you? The light ray comes from where? The light ray in this particular direction. Fish to the bird. The light ray is from where? Fish to the bird. But our observation is taken from where? From opposite to the direction of this light ray. From where? Bird to the bird to the fish. That's why only it is opposite to the our direction of observation, direction of our light ray. Okay, na? Observation is the direction of our light ray. It will be yes. And next one it is taken as n2 is equal to taken as somewhat n, n1 is equal to taken as somewhat 1 here. Here n2, this all the values are substituted in this equation 1. What will be get for us? N by minus y, it is equal to taken as yes 1 by n1 is what here? N1 is taken as here 1. That is only we are taken as 1 by minus x here. Now it is also written as n by y is equal to 1 by x. Okay, clear or not all of you students? Now y is equal to taken as what? Y is equal to taken as n into x. Y is equal to taken as n into x here. The y is the what actually? Y is the vertical shift whatever appear for us, that is only we are taken here. Understood not all the students? Here in the terms of refractive index only we are made. Suppose the water refractive index is the 1.5 suppose. Otherwise the distance between the fish to the bird is taken somewhat 2 meters. Automatically it will become what? 3 meters. It appear as a 3 meter distance. Okay, clear or not all the students? It's used as a formula for us. Okay, now when there is a light ray enter from, okay, yes, when the light ray enter from where? Generalized formula, it is a shortcut formula used for you. Okay, now for the which type of problems? When the light ray is enter from air to the water or air to the any refractive index. Okay, clear or not all the students? Whatever the vertical shift it will be there, not a lateral shift. We'll have one more formula for the lateral shift. Whatever the vertical shift is there, that is equal to what? Y is equal to n into x. Means when the light ray enter from air to one media, whatever the substance is there inside of that media, it is appear not actual height. There is a whatever the height will be there, that will be not actual height. Whatever the shift will be occur from the height, okay, now from actual height to the original height. Okay, clear or not all? Actual height to the appearance height, that will be calculated by y is equal to n into x. Okay, now I will give one more problem for you based on this one only. Numerically, it is not given numerically now. Yes, I am given numerically for you now. As I want to give for you that numerical problem. It is important for you. There is an examination. The question may be asked like that one. Okay, got it or not? I hope you got it. This is only the information about our whatever vertical shift purpose. Got it? Now, yeah. Now we are going with that our further component. It is only about what actually. It is the answer at A here. Further away, there is actual distance. It's the correct only. Okay, why? Because suppose in case y is equal to x will be get, it is become wrong. Whatever the first condition is a given, that may become wrong when it is a y is equal to become as x, but y is equal to not become x. Y is equal to nx here. Okay, now when there is in our observation, suppose let us be taken y is equal to x in this particular condition, automatically the image distance is equal to object distance. Means what? There is no shifting of our image. Okay, but here there is a what? Refractive index is the what? Main role played here. Because of the refractive index of water, actual image appearance is a varied, it's a distance from its actual position. Got it? This is only about what actually, this is only about our total of our image formation and all these things. Okay, now we will go through, okay, this further topic in this diagram only. What is that? Next one. Next statement is what have here? Closer than in actual distance. No, it is not a closer than actual distance. Second one. Here n is equal to y is equal to what will we get? A is the correct only. A is the correct only. But B, about B. Yeah, it is not actual distance, but it is a closer or otherwise apart. Okay, or away. How you say it is? Yeah, there is a what is there? Y is equal to nx. Y is equal to what here? Nx. Here, you know very well. N1 is equal to 1 and N should be greater than 1 or not? N1 is a what? Actually, refractive index of air. It is a 1. N is a what? Refractive index of water. Okay, you know very well. There is a refractive index of air is only equal to the velocity, whatever the refractive index of vacuum. Why? Because the velocity of air, velocity of light in air and velocity of light in a vacuum is the same. But it should be compulsory decreases when it is enter from air to the water. You know very well about this. When it is entered from air to water, automatically the velocity of light decreases. Because of that, it should be n greater than 1 or not? Yeah, it is n greater than 1. You know very well about that. N is equal to c by v. Okay, now for air, okay, c by c only. That's why it is a 1. But for a water it is n is equal to what become now? Yeah, there is a c by v, and v should be not equal to c. Okay, now v is a less than c here. V is a what? Less than c. Automatically it is a greater than the 1 or not? It is a greater than the 1. Okay, clear or not all the students? Here n is a greater than 1. Automatically y is equal to become what? It is should be compulsory greater than x or not? When n is greater than 1, automatically y is also greater than x or not? Simple mathematical observation only it is. Okay, that's why compulsory it is away from the actual position, not to the closer to the actual position. That's why B is a wrong statement here. Whatever the B is there, that is a wrong statement. Now come to here. One more thing. Yeah. What the observation is there by the our bird fish? There is a what? So moving faster than its actual speed. Yeah, it is correct only. The C is also correct only. Why? Because already we discussed y is a greater than x. Y is a greater than x means what? Okay, now yes, there is a whatever our fish will be there here. The fish is observed. There is actually it is there. It here. It is the distance at x. Okay, now for the catching of it, when it is a come towards it, okay, now it will be taken the what? Compulsory greater distance, traveling the greater distance in actual time. That's why that speed is also appear for us what? Greater speed only. Okay, clear or not all of you? What the given here? The sentences are given clearly here. Yes, moving faster than its actual speed. Which one it is a moving? Yes, faster than actual speed. Bird moving. The fishes appear. These all the things. Okay, bird is not. With respect to bird is not. With respect to bird, it will be again changes. Okay, opposite to this. Once you take this same problem based on the with respect to the bird. Here the problem is totally based on the what? With respect to fish. Once you take the same problem with respect to bird. Okay. Bird, with respect to bird, what is the position of our our fish? It is actually appear closer than the actual distance. Okay, clear or not all of you? It will be, in case it is a moving, it is looks slower than this actual speed. Why? Because you would not tell me here what we are considered. Yes, what we have considered, there is our body is moving with a constant speed. Okay, now yes, towards the fish. Bird appear that has a covered x distance from a certain time, but fish appear that bird has covered a distance y from its actual distance. Okay, now in the same time, the distance is increases, but the time is the same, and as well as that is reaches the same time for a long distance. What we require, the speed is increases or not? Okay, you know very well already. Yes, there is suppose the same example we have taken for numerically. Okay, clear or not all of you? There is a given somewhat numerical things only for it. Okay, now yes, whatever the water will be there. In the water there is a fish is there. Okay, clear or not all of you? The water is the contain the refractive index. There is a n2 is equal to 1.5, n1 is equal to 1. Our bird is at 2 meters distance. X is equal to 2 meter distance. Now, according to this information, whatever will be get, that is a what? Y is equal to what? Nx. Clear or not all the students? Y is equal to nx. Now, y is equal to taken as what? Y is equal to taken as 1.5 into 2, that is should become what? 3 meters. Actually, bird is appear at where? Bird is appear at 3 meters, not at 2 meters. For whom? For fish. Okay, clear or not all of you? But what we are thinking, the 2 meters is the travel by the bird is a constant speed and it reaches to the our fish actually. Okay, but the fish is not looks like that. Why? Because there is a bird is have to travel how much distance? 3 meters in the same time. Okay, we said that there is a 1 second time is taken for it. Okay, now for actually we are considered for constant speed with the time of a 1 second only we are considered here. Okay, clear not all of you? But it is not 1 second, it is below 1 second. Very small amount, a small time it will be taken. Here 1 second it is only taken, but it is a bird is 1 second. At that time, what is the speed? Actual speed is a what? Actual speed is written as written as what is the distance? 2 meter distance in a 1 second. Means what? 2 meter per second. But it is a 2 meter per second for the bird? No. Why? Because bird at where? Here. For according to whom? Fish. That's why the velocity has become what? 3 meter per second. Why? Because in a 1 second only it will travel to the 3 meter distance. That's why which one? The velocity is a greater or not? The velocity is a greater. I hope you understood from this numerical observation. Okay, clear or not all the students? Not only you take 1.5, you take greater than 1, whatever the value you should be take greater than 1, it not equal to 2 meter per second. It should be greater than the 2 meter per second only. Okay, got it? Yeah, in this way only you are taken about our problem. The D is wrong. Why? Because the speed is increases, not decreases. The constant speed value is increases, not it is in a decreasing. Okay, got it? This is only the information about our first example. Very important one for you. Okay. Example number 2. Now, important examples these all are. Don't take it as a numerical problem. There is somewhat analyzings are there about our refraction. In case the plane surface is there, the refraction is going like that. Already you have in your 9th class about the lateral shift and as well as there is a vertical shift. Okay, now this question is given at the second time after initiating of this new book. Okay, now yes, we feel somewhat hard in case the questions are given like this diagrammatical mode. Don't confuse about that. First you analyze the situation, what is there in that our problem. Okay, now yes, when they are given a diagram, when they are given a fish, and as well as once you observe the diagram, once when you are observed at the first time, automatically it looks somewhat difficult, but it is not a difficult thing. Okay, analyze it. Okay, clear or not all of you? Yes, now already I am given that the same problem you take with respect to the bird. Okay, clear or not all of you? The bird is up here the fish. Now the same options, which one is the correct, which one is the wrong. Whatever the correct for the fish, that become the wrong for the bird. Okay, clear or not all of you? Yes, and it is only called as optical hallucination. You know very well, hallucination. Okay, clear or not all of you? That is like a mirage. Optical hallucination is occur because of refraction. Because of the reflection, there is no optical hallucination may occur here. But because of refraction, there is optical hallucination may occur. Okay, clear or not all of you? Yeah. Now, actually, there is a come to second part. A transparent sphere of a radius r and the refractive index L is kept in A. At what distance from the surface of the sphere should a point object be placed on the principal axis so as to form as a real image at the same distance from the second surface of the sphere? Yes, and here that is only the diagram is also given. What is the diagram is given here? like this. There is a what here? We taken a sphere here, transparent sphere. Yes, and there is a whatever this transparent sphere is there, is the radius of this transparent sphere is, yes, here it is we taken as a transparent sphere. Here it will be taken as a transparent sphere. This is a taken some point O here. Okay, clear or not all this? It is a O. And now the light ray is come from where? Come from this point object. And one is through the principal axis. Another one is somewhat made angle with the whatever surface. And now there is a whatever the light ray. You know very well. It is a transparent sphere. There is no change in the light path. Where? From here to here there is no change in the path. Once it is refracted, okay, clear or not all of you? Yes, it is transparented through the sphere only. Okay. Now again there is a refracted the second surface also. Here it looks like a convex surface. That's why it is comes towards the principal axis. Okay, you know very well. This is the principal axis. That's why there is no deviation in the ray. Our light ray undergoes the 2 times refraction, one at here, another one at here. Okay, clear or not also? And now there is a what we are taken, that the radius is taken as r somewhat. The radius is taken somewhat r here. Okay, clear or not all of you? This is only become the what? Yeah, there is it is become the normal for this particular point. It is the normal for this particular point. Okay, clear or not all of you? One check it here. Why? Because it is the radius of curvature. It is a normal, it is the incident ray, and automatically it is bending towards the normal, it is a refracted ray. Then again here it is a normal, yes, and now it is a from where it is an incident ray, it is a refracted ray. It's a go away from the normal. When it is a go away from the normal, it meets at this particular point. Here you take here it is an image. Where there is image is formed? Image is formed at here. Clear or not all the students? Yeah, from the figure yeah, here we required what? Here we required the, yes, our real image is required, and once check it here, the distance from the object to the first surface is taken somewhat, it is the x, that is u, yes, and here we taken it is the v, yes, whatever the distance it is taken from here to here. Okay, clear or not all the students? Here we get the, we require the real image. Now, you know very well, when there is our refracted ray after the refraction of the first surface, it is parallel to the principal axis. Okay, clear or not all of you? When it is parallel to the principal axis, the real image is formed at this particular place only. Okay, that's why here there is a what is the position of our v? V is equal to taken somewhat, u is v equal to infinite, u is equal to already given, that is only x it is a given here. Okay, clear or not all of you? But there is a how you take our u value, it will be, yes, it will be taken minus x. Why? Because there is a image, this is moving in the direction. Our ray is moving that direction. We are considered from the distance from where? From the P to the O. Okay, now U is equal to PO, that is the minus x. Here V equal to infinity. Why? Because V is equal to y because infinity. There is our refracted ray after the first surface. It is a parallel to the optical axis. It is a parallel to the optical axis after the refraction from the first surface. That's why V equal to taken as infinity here. Okay, got it or not, all the students? Now, automatically, what is the formula for image formation? That is the N2 by V minus N1 by U is equal to N2 minus N1 by what? R we are taking here. Here, what is that? Here, N1 is equal to 8. N2 is equal to taken somewhat. What is the refractive index are given here? N is the refractive index here. Okay, clear or not, all of you? Automatically, N2 by infinity minus N1 by minus x is equal to taken as minus x is equal to taken as N2 minus N1 by R you have to write. First there is I am applied only here the distances only. Now there is a what will we get? This is become 0. Okay, now minus of minus it will become plus. Now it is written as minus 1 by minus of minus, that is a plus, that is a 1 by x. Okay, clear not all of you? Why? Because N1 is equal to taken as what? N1 is equal to 1, N2 is equal to taken from what? N. Okay, now it is also written as N minus 1 by R. Okay, clear or not, all the students? 1 by x is equal to taken as N minus 1 by R. Now automatically x is equal to taken as R by N minus 1. This is only the distance of the our object. We have to kept it where? For a real image purpose, we have to take the where here. Yeah, here we have to shoot. There is a kept at this particular distance R by N minus 1. At that time only you will get that our real image. Otherwise, there is a virtual images are get for us at this particular position, but we required what? Real images are required for us. Okay, clear or not, all the students? Yeah, I hope you got it. This is only the second problem. Tomorrow we will go with example number 3 and as well as the remaining concepts of our this fourth lesson. Okay now? Yes. Thank you students. Bye. Take care. I hope for best for our future days. Yes, whatever the decision may we are expecting for today. Okay, clear or not, all the students? Yeah. And now all the students, please do one thing only. Yes, whatever the first problem is there, you write. That is only your homework for you today for here. Yes, for a first problem, you take the problem with respect to the bird, not with respect to the fish. Okay, clear or not, all of you? Yes, with respect to the bird, what the changes are coming. Okay, now the fish appear nearer or farther from actual distance. And as well as in case the fish is moving, okay, clear or not, all the students? Fish is moving more than its actual speed, okay, now, or actually it is less than its actual speed. That is only we are going to discuss. Thank you students. Bye. Take care.